In this lesson, we're going to talk about concentrated solar power. Concentrated solar power is where you use large numbers of mirrors to focus light on a central place and make it very hot. And it's an alternative to the photovoltaic cells we've already talked about. So I'm going to explain how this works, its advantages, its disadvantages, and show some current trials of how it's actually operating. Now, there are concentrated solar plants out there in the world. Here is an enormous one called Noor 3 in Morocco. This is generating 134 megawatts with 7 hours of storage. So what you have is large numbers of these things which are called heliostats, which are basically mirrors attached to motors. The motors are able to maneuver the heliostat, and the idea is that each one of these heliostats, when the sun is up, will focus the light on a central tower, particularly the black part of the central tower. So you can imagine if all these mirrors are focusing the light on the central thing here, that central tower is going to get very, very hot. And that's what you use. You use that heat to drive a heat engine to generate electricity. Here's another plant, Crescent Dunes in Nevada, USA, 110 megawatts, 10 hours of storage. And once again, you can see large numbers of these heliostats, which will focus the light on this black part of the central tower, which will get really hot, and a heat engine there will produce electricity. There's actually a concentrated solar power dish right here at ANU campus, in fact about 100 meters from where I'm writing this. And it's a big dish, which focuses, rather than having separate heliostats, it's a single big dish, which can be pointed at the sun and focuses the light on the central focal container, which will get very, very hot, and in this case is used to produce steam. So here's how these plants normally work. You have the heliostats focus the light on the receiver. Now, if you just focus the light on the receiver, it would get so hot that it would melt. So what you typically have is a cooling fluid. You have a big tank full of a cool fluid. We'll talk about what fluid later. And that's pumped up to the receiver where it turns into a hot fluid. It gets very hot and comes down to a second tank, which is now full of very hot fluid. Then, when you want to get the electricity, you pump that hot fluid into a steam generator, generates hot high-pressure steam that drives a turbine and generates the electricity. And there you can see the major advantage of these concentrated solar plants, that what they can do is they can store the power for later. So you can generate the heat, have a huge tank, and you don't have to use that tank right away. You can wait until there's a period in the evening when the sun's not up, and then and only then you pump it into here. Of course, some heat will leak out, but if you insulate your tank, it may not be very much. So, why isn't everybody doing this? Well, as usual, the answer comes down to costs. Here are the costs in 2010 and 2021 of a whole bunch of different energy sources: fossil fuels, geothermal, hydropower, solar photovoltaic, onshore wind, offshore wind, and concentrated solar. And what you can see is that back in 2010, concentrated solar was probably cheaper than solar photovoltaics. Back then there were a lot of people thinking this was the energy of the future, but the solar photovoltaics prices dropped really dramatically, and the concentrated solar has not dropped so much. So it's now actually one of the more expensive forms of technology. If it's so expensive, why is anybody bothering with it? Well, the answer is storage, as we were saying. You can get the heat at a different time. You can store it until you need it. And there are many diagrams like this. This is showing what's the cheapest form of energy storage, depending how many times you must discharge your energy per year versus how many hours you store it per discharge. And you've got lithium-ion batteries down here. You can't discharge them too many times per year because lithium-ion batteries only have a certain number of charge cycles before they wear out. So if you discharge them 100 times a day, they're not going to last very long, which means you have to buy a new battery, which is going to be expensive. But if you're only discharging 100 or a few hundred times a year, and you only want to store up to an hour, they are the cheapest forms of storage in 2020. If you want more hours of storage, then pumped hydro is best. And if you want to store for a very long time, we're talking about compressed air is the cheapest. And there are other options: vanadium, reflux flow batteries, and flywheels if you need to discharge very many times a year, but that's not a very common situation. Looking into the future, by 2040, lithium-ion batteries will be cheaper and better, and they will dominate the entire bottom part of this chart. You'll still have pumped hydro and compressed air storage, and people are thinking that for the very long-term storage, particularly to store things in case of whole weeks when there's no wind and no sun, you might be using hydrogen. You produce hydrogen by electrolyzing water and then store it in a tank somewhere to burn when you need it. So this is storage, it's difficult, and it's possible that these diagrams might be rewritten somewhat if you had a lot of the concentrated solar power. They might actually be the cheapest for certain regimes in here. This is a diagram, it's now a few years old, 2018 and out of date, showing the cost of different forms of electricity if you factor in storage to make them reliable on a 24-hour timescale. And so you can see that green is the actual collection cost, and for solar photovoltaics that's extremely cheap. But then if you want it to be a 24-hour, you need to buy batteries, and the batteries are more expensive than the solar panels. So overall it turns out to be relatively more expensive. Whereas concentrated solar can be quite a bit cheaper. The actual generating the solar is more expensive, but you don't need to store it. You've got your tank full of hot fluid. I think these figures are pretty out of date and maybe a bit dubious, but nonetheless you can see that the benefit that when you factor in storage, concentrated solar may start being competitive with other forms like wind and solar photovoltaics. Another place it might be useful is for industrial heat. This is 42% of the energy consumption in Australia is industry, and a lot of that is actually heating things up, whether it be pulp in a mill to make paper, or aluminium smelting, or iron smelting, or various other things. And that's mostly done by fossil fuels these days, but if what you want is heat, then you don't have to worry about the Carnot limit. You can generate very high heat with these concentrated solars and use it directly for some plants, at least when the sun is up. So there may be a role for it here. It's a bit tricky because a lot of industrial plants will want to work 24 hours a day, and the heat, so storage can help for that, and they might not be located in the same place. These concentrated solar plants, you want to put them in a sunny place, preferably with cheap land, which means they're in the middle of the desert, which may not be where you want to have your plant. Workers may want to prefer to live in the city, for example, but it's at least an option.